well. The network was very poor. We ended some aspects in the general mathematics, which was basic logarithms. I went through all the 9 theorems that are required. So each and every one of you that will be interested in that must go through those theorems. If those theorems are under control, you can solve any question of your choice. Now what I will do for in today's edition, I will just get an highlight of how to apply these applications, how to apply those theorems. All the theorems that I went through, how are you going to make use of them? That is what I will be doing today. So if I now have a question, the question tells whatever way the question is put, I will use any one of the theories to solve the question. What I mean by that, let us say you have a question and you are asked to evaluate something like this. Let us say you want to evaluate log 16 base 2. Let us say you have a question like that, log 16 base 2. You want to evaluate that or to simplify that. I explained about 9 theorems that will be used. Any one of the theorems you think you can use correctly, you can use. And for you to be able to understand those theorems again, I will take my time to use them one at a time. The first theorem that we used was multiplication. The first theorem I explained on that day was multiplication. And how are you going to use the multiplication to solve this question? That means when a question is given to you, if we prefer to use multiplication, what are the things you do in order to use the multiplication? Now the same question that you are seeing here is what I am bringing down here, and it's still log 16 base 2. I have not changed that. But when you want to make use of the multiplication, you take 2 numbers, you multiply to get the 16. Have in mind the number here is 16. So when you want to simplify that, you make use of any 2 numbers that will give you a product of 16. That means you multiply 2 numbers to give you 16. The 16 here can be 8 times 2. It can be 4 times 4. If you want, you can even say 16 times 1. So for you to multiply 2 numbers to get 16, if you want to use multiplication, you multiply 2 numbers that will give you a product of 16. So if you multiply the 2 numbers here, we are getting 8 times 2, we get 4 times 4. If that happens, you can now replace 16 with any of the figures there. If we now prefer to use 4 times 4, that would be 16. If you want, you can use 8 times 2. But if I now prefer to use 4 times 4 for 16, that is giving me log of, instead of 16, I will now say 4 times 4. That is still 16. And the base here is 2. The last class we said anytime you are multiplying, when you are using multiplication, you always add. Anytime you are multiplying the logs, you add them. So if that is the case, I have 4 here and 4, I will take the log. Log is common, this log is common to the 4 and this 4. So I will take log of the first 4 plus, because of multiplication I add. The other 4 also, log takes down the second 4, and the base 2 is common to the 4 and the 4 here. We put 2 here and 2 here. Then we move further in the simplification. When you want to simplify 4, anytime you want to simplify 4, you can say 4 is the same as 2 times 2. 2 times 2 is 4. And 2 times 2 in mathematics is the same as 2 to the power 2. That means I have multiplied 2 times. I will just say 2. How many of them? 1, 2 is raised to that particular power. So 4 is the same as 2 times 2, and 2 times 2 becomes 2 square. Wherever we see 4, we put 2 squares. If that is the case, we have log of the 4 appears here, it becomes 2 square. And the 2 that is down here comes. Plus the 4 here becomes again 2 square. And the 2 here comes down. Again, last, if you can recall, we said anytime there is a power, when there is a power to a logarithm, you always drop that power. Anytime you have a power, the log is raised to a power, you drop that particular power. So if I'm bringing a power here down, the power is 2. If I bring that down, I will get 2 log 2 base 2. Again, there is a power here. If I want to bring that down, it becomes 2 log 2 base 2. If you can also recall one of the theorems that I dealt with, the theorem says anytime the log and the base they are equal, the result is equal to 1. Anytime the log value and the base they are equal, the answer is equal to 1. In this case, the log is 2, the base is 2. So the log value and the base value, they are the same. So the answer is equal to 1. If that is the case, we have 2 times 1 plus, again here is 2, log base 2, log of 2 to base 2 is also 1. 2 times 1 is 2, plus 2 times 1 is 2. 2 plus 2 becomes 4. That would be an answer if you want to use the multiplication. Let us say you are not interested in that multiplication. You don't want to use multiplication to solve that question. How are you going to solve that question using the other theorem? We go to theorem 2. That was purely division. If that is the case, the same question is what I am bringing, but I use the second method. I have log of 16 base 2. I will now look for two numbers I will divide. I want to use division, so I will use two numbers that I will divide to get 16. Two common numbers I will divide to get 16. One, I can say 32 divided by 2. When I say 32 divided by 2, that will give me a value of 16. So in short, I will just, if I want to use division to solve that question, I will look for any two numbers that I will divide to get the 16 here. Two common numbers we can divide to get 16 are 32 and 2. 32 divided by 2 will give me a quotient of 16. So wherever I now see 16, I will put 32 divided by 2 because I have not changed anything there. If that is the case, I will put here 16 is 32 now divided by 2, but the base is 2 here. If you can recall theorem 2, the one we discussed, anytime you are having division, you subtract. Anytime you are dividing log, you subtract the values. So how are we doing that? The 32 and the 2 again, they belong to the log. So what comes here will be log of, you take the 32 first. Because of the division you subtract, we have 2 here, that is log of 2. Now the base 2 is common to 32 and 2, so the base 2 is here and here. We again further with the simplification. When you see 32, 32 in multiplication is 2 times 2 times 2 times 2 times 2. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 becomes 32. So that means we have multiplied 2 5 times. We have 1, 2, 3, 4, 5. We have multiplied 2 5 times. So wherever you see 32, you put 2 to the power 5. If that is the case, we now have log of 32 is here. It becomes 2 to the power 5 base 2 minus. Now when the log and the base they are equal, the log value and the base value they are equal, the answer is 1. The theorem further, there is another theorem that further states that anytime there is a power to a log, you drop that power. Now if I am dropping the power here, the power is 5. The one that is raised here is the power. You drop that down, you are having 5 log 2 base 2 minus 1. The same theory applies when the log and the base they are equal. The log value and the base value they are equal. 2, 2. The answer is 1 minus the 1 here. 5 times 1 is 5 minus 1. Answer will give you that gives you an answer of 4. So if you want to use a division, that is what you want, you can get. Now let us say you are not interested again in division. You want to move further to another theorem. So you will now have to understand all the theories that I explained. That is the more reason I am solving this question using all the theorems. Let us say you are not interested in division as well. You want to go further to another theorem. But the question is still log 16 base 2. That is what we want to solve now using another theorem. If I want to solve this question using another theorem, what comes to mind is that 16. We agree that 16 is the same as when you say 2 times 2 times 2 times 2. If I say 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. So for me to get 16, I will say 2 times 2 times 2 times 2. And that means we have multiplied 2 4 times. That is 2 to the power 4. 1, 2, 3, 4 of them. 2 appears 4 times. That is what I have just written there. So if that is the case, wherever we see 16, we put 2 to the power 4. If I come to the expression here, instead of 16, I know now it's 2 to the power 4. That is 2 times 2 times 2 times 2. The base is 2. The theory further states that anytime you have a power, you drop that power. So if that power is dropped, the power we have here is 4. If it drops down, you are having 4 log 2 base 2. Now that is because 4 log 2 base 2 answer is equal to 1. When the log and the base they are equal, the result is 1. So that gives you 4 times 1. Answer is given us 4 as an answer as well. If that is what you are interested in. Let us say you are not interested in that theory as well. You want to move further to another theory. And how are you going to get that theory? Theory 4. We still have log of 16 base 2. The theory says if you want to solve using that particular theory, you divide the expression. How are you going to divide them? You take log of the value that is at the top, divide by log of the value that is at the bottom here. So if that is the case, I will now say log of 16 divided by the value that is at the bottom is log of 2. But a few minutes ago, I said 16 is the same as 2 to the power 4. Wherever you see 16 is the same as 2 to the power 4. So if I put 16 as 2 to the power 4, that is what I will get. I have to divide that by log of 2. Now, there is a power here. Anytime there is a power, you drop it down. So this power has to be dropped. I will drop this power down. I will now have 4 log 2 divided by log 2. Now log 2 cancels log 2. When log 2 goes here is 1. 1 into 1 here is also 1. 4 times 1 will give you an answer of 4. Let us say you are not interested in that particular theorem as well. You don't want to use that theorem also to solve this question. The other theorem you want to use now is the last theorem, when the log is equated to a value. That will be another way you can solve this. When the log is equated to an unknown, any value of your choice. And the question is saying log of 16 base 2. I will have the right to equate this one to any value or any letter of my choice. If I want, I will say let this one equals x. That means I will just take that question and equate it to any letter of my choice. That means there are 26 chances here from A to Z. So if that is the case, the theorem now, this theorem, when the log is equated to an expression, says that the answer always becomes the power to the base. Whatever answer we have here is becoming the base, is coming here to become the power. So I will take the base, whatever that is down is what I have used. Now the answer is x here. That x become the power here. Become the power here, and that is equal to 16. If that is the case, few minutes ago I said 16 is 2 to the power 4. Anywhere I see 16, I will just say 2 to the power 4. If that is done, the equal basis will cancel. This is 2, this is 2, they will cancel. So my answer becomes 4. Let us say you are not interested in that as well. You don't want to use that method again to solve that question. You move further to the other theorem. That makes you now a very good mathematician. So you can solve that using another theorem. And that theorem is now, let us say it is now at number 5. That means it's the number 6 method now we are using to solve that question. And the same question, the question is log of 16 base 2. The theorem that we want to use now is the reciprocal theorem. And what does the reciprocal theorem state? The reciprocal theorem states that anytime you take the reciprocal of the log, you are to take you interchange the values. Anytime you take the reciprocal of the log, you interchange the values. That is the theory we want to use. And if I want to use this one, the reciprocal becomes 1 divided by. Anytime we say reciprocal, we mean 1 divided by any expression becomes the reciprocal of the expression. So if I take the reciprocal of this one, I will have log of, instead of 16 at the top, it is 2 that is now going upwards, and the 16 comes down. That is what we want to bring here. Now we can proceed further to simplify this. We are having 1 divided by log of 2. 16 is here. Wherever we see 16 is 2 to the power 4. So wherever 16 appears is 2 to the power 4. If you can also recall one of the theorems that I explained, anytime the base has power, the base is raised to a power. You also take 1 divided by that power before you multiply by the logarithm. Anytime the base, where it is the base that has the power, you take 1 divided by that power before you attach or you put before the log. How can I apply that here? When I come here, I have 1 divided by, now the base, this 1 value down here is 2, which is the base. The base is raised to a power now 4. So when I want to simplify this, I will say 1 divided by that power, then I put before the log, which now comes before the log, which is log 2 base 2. So if we continue with that, it becomes 1 divided by 1 over 4. Log 2 base 2, answer is 1. So that is giving us 1 divided by 1 times 1 is 1 divided by 4. In primary school, when you see this line in primary school, we say division, that way. That is 1 divided by this line is known as division line, 1 over 4. So that will give us 1 times, the 4 will go up, and then the 1 comes down. That is the division rule. Anytime you change division to multiplication, you interchange. So if that happens, you have 1 times 4 is 4 divided by 1.